All right, guys, questions on the homework before we get started?
No, I'll bring it.
Again, all of Chapter 1's assignments are due at the end of the day today. Otherwise, they will be zeros. Yep, Chapter 1. All of Chapter 1's homework's due at the end of the day today. So, first thing we're looking at is this here, minimum and maximum value. So minimum value, maximum value is the highest or lowest point of the parabola's y value. So if it's opening up, it will have a minimum value at that y value of the vertex. If it opens down, the y value of the vertex would be a maximum. So if we get the vertex, we'll have the minimum or maximum value for that there. The domain is understood to be all real numbers. No matter what the quadratic equation is, it's always going to be all real numbers. Now, if the quadratic equation is opening up, so here on the left, the range, just y is greater than or equal to whatever the minimum value is. So if it's opening up, the minimum value is the smallest y value we can have, and then we have all the other ones bigger than it. If it's opening down, the range is going to be smaller than whatever the maximum value is for y. So it's just that value and less than it. Increasing, decreasing. Increasing and decreasing, we're talking about left and right. So decreases to the left, or increases to the right. And when we look at that and talk about that, let's get a highlighter. All it's saying is we read from left to right. So is this function here coming from left to right to the minimum, the graph is going down towards that vertex. After the vertex, the function is going up. It's increasing. On our other one here, as we're coming from left to right, it is increasing. And once we get to the vertex, from there over, it is going to be decreasing. And normally increasing and decreasing we write as intervals going from left to right in terms of the x values. We're just saying along what x values is it increasing or decreasing. So we look at this first one here. We want to find the minimum or maximum value of this function, describe the domain and range of the function, and where the function is increasing or decreasing. Well, really the main thing we need to find with this here is the vertex. Because if we have the vertex for this function, we can find the rest of the information here. Now our vertex for standard form, because this is in standard form, our ax squared plus bx plus c here. Let's leave the items alone. Let's pay attention to this here. We can use that to find our vertex, because our vertex, as it was given to us for standard form, is negative b over 2a, comma f of negative b over 2a is this value. Now for us here, our values of a, b, and c, what would a, b, and c be? Negative 2, negative 1, 1/2, negative 2, negative 1. So to find the x value of the vertex, we're going to find our negative b over 2a. So we'd have negative 2 over 2 times a. Now at this point here, we can do it by hand or we can do it in the calculator. So the 30xs, so negative 2 over 2 times 1/2 would give us questions on how we got 2. which means the x value of the vertex will be 2. Now to find the y value of the vertex, we're just going to plug 2 in for x. So we'll have 1/2 times 2 squared, minus 2 times 2 minus 1. And again, we can plug this into the calculator. 1/2 times 2 squared minus 2 times 2 minus 1 is -3. So our vertex is the point 2, -3. Now this is not specifically asked for in this problem, but it does give us everything we need. Because if we look at this here for minimum maximum, is going to depend on how it opens. If the value of A is greater than 0, it opens up. If value of A is less than 0, it opens down. Well, here the value of A is 1/2, but it is positive, which means it opens up, telling us that we will have a minimum value of -3, because the minimum value is the y value of the vertex. And that's it for our minimum maximum, because there is no maximum for this here, there's only a minimum. Now the range for this here is going to be compared to -3. In that, if it is a minimum value, y is going to be bigger than it. If it's a maximum value, it's going to be smaller than it. But since this here is a minimum value, we're saying that the y value is greater than or equal to it, that it's going to be all of the y values from -3 going up. Because when we talk about the range, we're talking about the y values that it's covering. What values of y come out of the function? Well, all the values greater than or equal to -3, because -3 is the smallest. All the rest have to be bigger. The domain is all real numbers. Our domains are x values. We can plug any x value into this function and it's going to work just fine. So domain's all real numbers. So that's the nice thing with these here, because domain's going to be all real numbers for most all of them. And the last thing we have is increasing and decreasing. Increasing and decreasing. Now, in the general form here, it really tells us to the left of this, to the right of this. Now, the other way we can find it is, well, looking at the graph. And this here is the graph. I've already typed it in for us. We have it here. So as we go from the left to the right, so increasing, decreasing, we always start at -infinity. And as it shows up here on this graph, it is coming down. It's decreasing here. So from -infinity to that vertex would be decreasing. So decreasing as an interval would start at -infinity and would go to the vertex. And we talk about this purely in terms of x. Well, the x value of the vertex is what? 2. So on the interval of -infinity to 2, the function is decreasing. And at that point, it changes and would be increasing. For parabolas and quadratics, there's only one set for each. Now, it is possible to have more than one set increasing, more than one set decreasing, going up, going down. But with parabolas, we'll only have one of each. And it is possible to have none, because a straight line is either going to be always increasing or always decreasing. It's one or the other. So I just wanted to show you all that so we've at least seen it. We kind of talked about it before. But that's it. Because the last thing I want to talk about is this here, x-intercept form. Now, part of the reason we call this x-intercept form is because P and Q are the x values where it crosses the x-axis. P and Q are the x values where it crosses the x-axis. So if we know the values of P and Q, we know the x-intercepts. Now, the vertex is given to us by the equation P plus Q over 2, comma F of P plus Q over 2. And the axis of symmetry is x is equal to P plus Q over 2. Now this one here, we only have one other thing that we need, is that's the x-intercepts. And the x-intercepts are P comma 0 and Q comma 0. So these are the main forms we have for this here. And we're going to use them to find this here. Now I realize I need to fix these a little bit so you don't have the graph taking up half of your note sheet. But the key thing with these here, and to be able to solve these here, not plus, is first finding the value of P and Q. Because if we can find the value of P and Q, we have everything we need to be able to calculate the rest of this here. So looking at the equation in the general form, so one of ours is P minus, or x minus P. Well, it lines up with x plus 3. So the value of P we can say is 3, but would it be positive or negative? It'd be negative, because the only way to go from x minus P to x plus 3 is if the value of P is negative. That's the only way we can change the sign. Our other one is x minus Q is matching up to x minus 1. So the number for Q would be 1, but would it be positive or negative? Positive, because x minus P, x minus 1, Q is indeed 1. Okay. Now I'm going to scoot down just a little bit here, because one of the things that we do need is the vertex. And we also have the axis of symmetry. Well, the vertex, the standard form or general equation for this is P plus Q over 2, comma F plus P plus F of P plus Q over 2. Axis of symmetry, x is equal to P plus Q over 2. And these are really the only 3 things we need to calculate for. Well, actually 2 things. Because we need to find out what P plus Q over 2 is, and F of P plus Q over 2. Let's start off with P plus Q over 2. Well, our P value is what? And Q is So we're taking negative 3 plus 1 over 2. There's two ways we can do it. One, we can do it by hand. The other, negative 3 plus 1 over 2 is negative 1. We can do it in a calculator or we can do it by hand. Both work. Both should give us the same answer. So, x value of the vertex is negative 1. Our axis of symmetry, x equals negative 1, because that's our p plus q over 2. Now our f of p plus q over 2 is exactly what we did yesterday, our f of negative b over 2a. All we have to do is take this value of negative 1 and plug it back into the equation. So for us here, we have negative 2 times negative 1 plus 3 times negative 1 minus 1. Again, we can do this by hand, or we can do this in the calculator. Both work just fine. And here we get 8. So with that there, we do have the vertex and axis of symmetry. Now the only thing that we're missing is the x-intercepts. Now the general form for x-intercepts is p comma 0 and q comma 0. Well, we already found p and q. What's p's value? Negative 3. And q is 1. Yeah, negative 3, 1. Questions on this here? Because really, once we got p and q, we had the x-intercepts. To get the vertex, we had to add them together, divide by 2. And it also gave us the axis of symmetry. To find the other part of the vertex, we just had to plug that value back into the function, and it gave us the rest.
Could Caitlin please come to the front office? Thank you.
If we're to graph this, negative 1, negative 8 would be this point here. Negative 3, 0 would be one of the x-intercepts. 1, 0 would be the other. Axis of symmetry. And that'd be our graph. Right. Questions on this here before we move on to the next one? Let's look at the next one. The graph f of x equals negative 1/3 x minus 4 times x plus 2. So, comparing it to the general form, first thing it'd be good to find is p and q. So what would our p value be? So it would be 4, but it would be positive or negative. So we look at it compared to the original, so x minus p, x minus 4, yes? X's line up, minuses line up, so p is 4. Let's look at the next one. So we have x minus q and x plus 2, yes? So q will have a value of 2. But in the general form, x and q are being subtracted. In the equation, the x and 2 are being added. The only way I can go from subtraction to addition is if the q's value is negative. Because really, we could think of this as x minus negative 2 for it to line up. So when we're coming out of those parentheses, especially for this here, the value or the sign looks like it's flipping. Because when it's minus negative 4 or minus 4 inside, it comes out as positive 4. When we have positive 2 inside, it comes out as negative 2. Well, why don't we go on and do our main two calculations for this here, which is our p plus q over 2 and f of p plus q over 2. So p plus q would be 4 plus negative 2 over 2. And again, at this point, we can do this in the calculator. 4 plus negative 2 over 2 is 1. And our f of p plus q over 2 is just taking this value of 1 and plugging it back into the function. So we'd have negative 1/3 times 1 minus 4 times 1 plus 2. And again, at this point, we can plug it in. Negative 1/3 times 1 minus 4 times 1 plus 2. Which gives us 3. So our vertex in the general form was our p plus q over 2, comma f of p plus q over 2. So we found the p plus q over 2 to be 1. And when we plugged it back in, we got a value of 3. So the vertex is 1, 3. The general form for the axis of symmetry is x is equal to p plus q over 2, which in our case, it would say x is equal to 1. And our x-intercepts are p comma 0 and q comma 0. Well, what's our value of p? 4, and q is?
Hey, Lynn, please come to the office. Hey, Lynn, please come to the office.
That's it. Questions on this here? Do we need to see another example of one of these? Okay. We feel good with those there. That is it for today.